Okay, so in 9.6 we're going to talk about rational functions. And this word rational is kind of a fancy math word for the word fraction. So if you ever see that word, they're talking about a fraction. And we just write that down in here. A rational function is an equation with a fraction. And I probably should say, and a variable in the denominator for example, maybe something like y equals 1 over x. Inverse variation is saying to us as one variable increases, the other decreases. What that usually looks like, if you're writing down some examples, is something like x times y equals some number like 10, or sometimes it can be written as y equals some number over x. This is called an inverse variation equation. X is on the bottom, some number on the top. Could have been a 1 on the top, like in our red example up above. Could be a negative number. And so what ends up happening, like for example, if you think about it, 10 goes in for x. That means the y would be a 1. Okay, let's say we started there, 10 times 1. But if I make the x a 2, which means the x went down from 10 to 2, that means the y went up from 1 to 5. So as one variable's value is going down, the other one is going up, or vice versa. That's what an inverse variation means. So pick a number for x, start there, see what the y is, and then either go up or down and watch what happens to the y value in order to produce the number on the other side of the equation. So like for example, x is 1, y is 10. X is 2, y is 5. As the x was going up, the y was going down. That's called inverse variation. And then our last vocabulary with some subparts is what an asymptote is. Asymptotes are lines that a function gets close to but never touches. And they're usually represented by dashed lines. Sometimes our calculators have difficulties with that. You might see a solid line, but they're actually dashed. For some examples down below here, an example for a vertical asymptote might look something like this. In an equation, y equals 1 over x minus 5. And then you would have the vertical asymptote, which I would represent with the letters VA, to tell you that we're talking about a vertical asymptote. And that would be when x is 5. Or in other words, it's whatever value makes the denominator equal to 0. So that's the equation of a vertical line where you get close to it, but you never touch it. In a horizontal asymptote, that would be something like y equals 2x over x minus 5. Or you might have something, if you were to rewrite this kind of a deal, maybe you would see something in a different format like y equals 1 over x minus 5 plus 2. And what ends up happening is, oftentimes when you have a rational function, if you take the limit as you go to infinity, which you'll learn a lot more about in pre-calculus, what you'll find out on your table, and then also algebraically how to do it, is that this purple function goes to the number 2 as x becomes really large. So if you think about what's happening here on the top of this fraction, if you put in like 1,000 up there, you have the number 2,000. If you put 1,000 on the bottom, you have 1,000 minus 5, which is 995. 2,000 divided by almost 1,000 is the number 2. Written the second way, if you put 1,000 in the bottom, the denominator of the fraction is so large that 1 divided by that is almost nothing. So you're still getting closer to the 2. So there are two different kinds of ways you might see this. And that would produce a horizontal asymptote. So in the first example, what we're talking about, a vertical asymptote would be a dashed line that looks like that. And in the second one, a horizontal asymptote would be a dashed line that looks like this. And you'll see that as we do our examples. So in these examples, you'll notice that they talk about these translation things that we did our absolute value graph on. And whenever you were grouped with the x thing, I noticed down below here, x plus 3. That x plus 3 is telling me that this graph has been translated left 3 units.
X plus 3.
Yes, x plus 3 means it's gone left 3. The vertical asymptote will be whatever makes the denominator equal to 0. So you say the number that makes the bottom equal to 0, or the denominator, is x equals negative 3. And the horizontal asymptote will be whatever happens when you put a humongous number in for x, like 1 billion, and see what the y value is going to turn out to be. So imagine you put a number like 1 billion in for x, and you have 1 divided by 1,000,003,000. That number is going to be super, super, super small. Or in other words, it's going to be pretty close to 0. So the answer to the last part here is that your horizontal asymptote will be y equals 0. Now, if you wanted to see a picture of what this thing is looking like, what I would do is off to the side here, I would draw my coordinate axes. I will have a vertical asymptote at x equals negative 3, so here it is. Here's the number negative 3 on the x-axis. I will have a horizontal asymptote of y equals 0. So that's a dashed line horizontally at y equals 0, which is the same thing as the x-axis. And if I were to graph this thing and I ran out of room on the left-hand side, you would see a graph that looks like this. You can actually check this out on your calculator, and this is what you'd see. You'd see the same kind of thing over here on this side. You'll notice that at the beginning we said the translation was left 3. That's because way back up here, when we talked about this graph, 1 over x, which is kind of what they call the general inverse variation graph, that graph, if I were to graph it, looks like the following. If I draw a coordinate axis system, its general shape looks like this. And so that red graph has been slid to the left 3 units, and that's what we see down here on the left-hand side, is that the coordinate axes in black have been kind of moved over to where the blue and the purple are, and that's where the new graph is drawn. So that's what the translation of 3 to the left meant. If we look at B, B on the other hand, if I talk about what's going on there, I know that this graph has been translated right 7. I know that I have a vertical asymptote, and if I plug in the humongous number again for the x, like 1 million, 1 million minus 7 is 999,997. 1 divided by that's a really small number. So I was talking about my horizontal asymptote. My horizontal asymptote will be y equals 0. again, just like my previous one. And the number that goes for the vertical asymptote works the same as what we wrote down in orange, which means that I know that it's going to be x equals that number, 7. So as I graph this thing, like the previous one, I know that I have a vertical asymptote at 7, so that's somewhere over here. X equals 7. I know I have a horizontal asymptote along the x-axis because that's y equals 0. And if I graph it, this is still the same kind of graph as it was before. Now this time it's been shifted to the right 7 instead of left 3. So, good question asked, will the horizontal asymptote always be 0? It's a great question. The answer is no. So in D, we have two things that are going on. We not only have the fraction, but we also have the constant being added on to the right. And what that means for us is that, first of all, I know that the translation was 2 to the right, but I also know that it went up 4. And what that means for us for the vertical asymptote is that x is equal to 2, and this time the horizontal asymptote is y equals 4. Because remember when it's whatever with the grouping symbol, the x junk, it was left and right, the opposite of what you see, but whenever it was the y stuff, it's the same as what you see. So if I wanted to graph this one, and I drew a coordinate axis system on it, I would put my vertical asymptote at 2, so maybe somewhere right around here. I would put my horizontal asymptote at 4, so here's 4, here's 2, and then I would draw my graph. And your asymptotes become your new coordinate axis system, so to speak, and you just redrawn it. So in this very last one, what happened to the graph?
Flipped over the y-axis.
Excellent, flipped over the y-axis. So I write down, I'm going to use the word reflected instead of flipped. Reflected over y-axis. The vertical asymptote is x equals 0. In these asymptotes, you have to have an equation, which means there's an equal sign. If on the test coming up next week you don't put an equation, you're not going to get credit. If you just write down 0, I'm going to write down y equals 0, and you're wrong. So make sure you have x equals 0. The horizontal asymptote is at y equals 0. And so this graph pretty much looks the same as our original graph. The only difference is, in this particular graph, now I see this. Instead of in quadrants 1 and 3, it's in 2 and 4. So instead of looking at